Hi, good morning. Today we are going to define exactly how much a single joule is. In order to do that, first let's talk about a concept called specific heat. I'm going to write that down. You should too. Specific heat is like inertia for heat. Remember, inertia was how difficult it is to change an object's motion. Like this rag I have. I use this rag for an eraser. It is very easy for me to change its motion, moving it up and down with complete ease. It's not difficult at all. In contrast, I've got a 10-pound weight. This is much more difficult than the rag to move up and down. Eventually, I would get tired and I wouldn't be able to keep doing this. The rag, you do it all day. In the same way that objects of different masses have different inertias and it makes it harder or easier to move them around, different substances have different specific heats, which makes it easier or harder to heat them up or cool them down. It's basically inertia for temperature, which makes sense because remember, temperature is just the change in the motion of those particles. So I've got all these particles whizzing around at different speeds, and if I heat the substance up, they're going to move faster. If I cool it down, they're going to move slower. But they're always going to be moving. So specific heat is defined as the amount of energy, you should write this down, needed to raise the temperature temp of 1 gram, 1 degree Celsius. So whatever the number is for the specific heat, that's how much energy is required to raise the temperature of 1 gram of that substance 1 degree Celsius. Let's just draw a box here, box of water. Okay, got a little cube. Fill it with water. Remember, it only works if you make the sound effects. And then this would be 1 gram. We're calling this 1 gram of water. So this is 1 gram H2O. If I wanted to raise its temperature 1 degree Celsius, then I would need to put in 4.18 joules of energy. So today, this is what we're going to do. We're going to take our data from yesterday that we already have in a graph. We should have this in a graph, we should have it in a table. It should be very convenient for us to look at. And we're going to use that data to calculate how much energy was either released or absorbed from the water. Remember, it's the water that changed temperature. When we dumped these ionic salts into the water, they dissolved and either released or absorbed energy. How do we know if they released energy or absorbed energy? Well, that's whether the temperature went up or down. If the substance released energy into the water, it gave energy to the water and the water would heat up. So that was the potassium hydroxide. So let's draw that out. So we have these graphs. I've got KOH, I've got a certain mass, I've got a change in temperature, I've got a volume of water, so we'll say VH2O, and what else? And then I've got my specific heat, which we denote that with a little C, I'm not sure why. So then I'm going to write energy right here. Okay. So you might be able to see already that I'm just making a little table here to make it easier for me to look at my data. The volume of the water stayed the same in each case. The specific heat of water is going to be the same in each case. Okay? So all we need to do is fill in our masses. So this is going to be for KOH, that's 5 grams, 10 grams, 20, 40, and 80. Let's make a little line over. It's easy to look at. Okay, the 5 grams, what was my change in temperature? My change was 4 degrees. change in temperature at 10 was 10 degrees, followed by 21, and then it was 40, and then 72. Then the volume of the water, this was, for the KOH, 100 milliliters. Okay, and the specific heat in each case is 4.18. And then I can just calculate the energy that was used. Now this is a very easy calculation because all I'm trying to do is take that 4.18, and we're going to use labels so that we can understand this a little better. 4.18, and that's joules, remember that's energy, per degree Celsius. Let's write degree Celsius there. Degree Celsius. It's also per gram. So what I need to do is I need to take my temperature change and my volume times this number, and that will tell me how much energy I actually used. Now, why am I using the volume of water? Well, water is very convenient in that 1 milliliter of water is equal to 1 gram of water. So when I say I've got 100 milliliters of water here, I really have 100 grams of water. And that's what I'm going to need to use in this calculation. So it's really easy. I just made this table and I'm going to just multiply across. These labels are just so I know which time I'm thinking of. I'm not going to use the masses in my calculation. So let's actually block those off with another color. So I've got these guys that are not going to be used in the calculation. These are just labels. Then I've got these guys that are multiplied together. And that'll give me the result of the energy. So let's do the first one together. So I've got, at the mass of 5 grams, my temperature went up 4 degrees for 100 grams, and it's 4.18 joules per gram. So I just take 4 times 100 times 4.18. This is already a fairly large number. It is 1.1672 joules. So 1,672 joules were released when I put 5 grams of potassium hydroxide into the water. So next I'm going to show you how to actually adjust your document to put these calculations in there. That's something that you're going to do. You're going to modify your document. So I'm going to have to return all of these. So don't return them back to me yet. This is our last step in making this document. We're going to make these calculations and then finalize your observations and your questions. I want 5 of each. 5 of each. And I'll reestablish that next. Step in modifying this document. What we're going to do is hit enter a couple times, and right below your data tables, right above your graphs, we're going to add in a section called calculations. And in this section, we're going to do just like I did on the whiteboard. And we're going to add in insert table. I believe it was 4 by 2, 3, 4, 6. I'm going to add in a table. This one's going to be for potassium hydroxide, so put our masses here, 5, 10, 20, 40, and 80. So this is our mass. I'm going to move this over because I like to keep organized. And then we're going to add in our change in temperature. So this, if you want to, you can just come up here and copy that. So I have a special keyboard that lets me type those Greek characters because I'm a giant nerd. So then over here, this is potassium hydroxide. We're going to put a 4, 10, a 21, a 40, and a 72. I'll move this over. Once again, organized. All right. Now, oh, I was wrong. We need one more. Okay. We're going to put in our volume of water. For each case, this is going to be 100. So really, you can just highlight this, copy it, paste, 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 paste. Good. And then we need our specific heat of water, which was just labeled with a C. That's going to be 4.18 each time. Again, we can just paste that. All right, and then I need to add in insert column right. Okay, so you guys should just make this right away with the right number of columns. I'm just going to get this a little better looking here. There we go. That's better. Then energy. So what you're going to do is you're going to take these three values and just multiply them together. So we did that on the whiteboard together. So 4 times 100 times 4.18. That was, let me see, is my calculation still there? It is, right there. 1,672 joules, okay? And I want you to label all these values. So this would be grams, grams. This will be degrees Celsius, so just put a capital C for Celsius. Let's give myself some more room here. So you're seeing me midpoint organization. I haven't already decided how to do this. There we go. And then that's going to be 100 grams. We're going to use grams for this because 1 gram of water is the same as 1 milliliter of water. And the units are kind of complex, so don't worry about it. Then over here, you're going to calculate out all your energies, put them in these tables, and then label it with a J. So do that for all of the temperatures for the potassium hydroxide, and then make a second table. So insert table, and this time I'm going to put the right number in. 5 by 6. And this one is going to be the same thing, same things at the top. Is that delta T? Just grab that from me. Boop. Volume of water, and then specific heat, energy. And then here, this is going to be for the ammonium nitrate. So put ammonium nitrate right there. Put potassium hydroxide right there. Let's give this another enter to keep it all on the same page. So there we go. Then put in all your values here. Remember, your masses are just going to be right here. I think I can actually just copy. Paste. Yeah. Beautiful. Love it when that works out the way I expect it to. Let's make that nice and simple. And these would all be 50 grams. Oh, don't do that. And then this would be the same as this one. It's always going to be that 4.18. Now the only difference here is this is a negative number, so this is also going to be a negative number. It's going to be a negative amount of energy, right? Okay, there we go. So make those calculations, and then come down here to the bottom here. I only have 3 here for observations, but I want 5. I want 5 total. The ends are just so I can enter and make more numbers. So I want 5 observations, and I want 5 questions, okay? You put a lot of work into this. Let's make it count. All right. So once you've done that, once you've got your calculations done, once you've got 5 observations and 5 questions, you can go ahead and turn it in. So if you've already turned it in, you were not supposed to. I did not tell you to do that. And I will go ahead and release it back to you. I'll return the document back to you so that you can re-turn it in after making